Hey everyone, Nitesh this side. Hope you're doing good. Sorry I was not available due to some emergency. So let's start with the question. So the question, let's open. So our streak is also break. Okay. So the question is graph bipartite? Okay. So we have, you can see there is an undirected graph with n nodes where each node is number between 0 to n minus 1. Okay, so your node value is from 0 to n minus 1. You are given a 2D array graph. So you are given a 2D array where graph u is an array of node that node u is adjacent to. Okay, so basically it's just a representation of graph. So your graph u will represent all the edges that is connected with it. So if I show you an example, so as you can see, 0 is connected to 1, 2, 3. So in the 0th index, it is connected to 1, 2, 3. Similarly, 1 is connected to 0 and 2, so it's showing 0 and 2. Okay. So what you have to do, so the graph has the following property. There are no self edges. So self edges is basically the same vertex is not connected to the same using a edge, so it is not there. There are no parallel edges, so only one edge at a time from two vertices. And if v is in graph u, then u is in graph v. The graph is undirected, basically means, as you can see, 0 is connected to 1 and 1 is also connected to 0. So in the, if you see in the array, 0 have 1 in the connected vertices, similarly 1 have 0 in their respected list. The graph may not be connected, okay, meaning there may be two nodes u and v such that there are no path between them. Okay, so there might be a vertex where there is no edge between them. Okay, so what you have to do, you have to basically find out whether the graph is bipartite or not. Okay, so what is bipartite? If the node can be partitioned into two independent set A and set B, such that every edge in the graph connected a node in set A and a node in set B. Okay, so let's understand what is bipartite. Okay, so let's take this as a bipartite. So what is bipartite? So bipartite is basically your each vertex basically belong exactly one of the two set, and each edge connect vertex of two different sets. So what does it mean? So let's take an example. So let's take a graph. So this is our graph: 1, 2, 3, 4, 5, 6, and this. Okay, this is a directed graph given to us. So let me arrange this. Okay, so let me arrange it like this. One, I'm just putting odd number side by side. So 1, 3, 5. This is my node, and let me take the even 2, 4, 6. Okay, it's not like I just put it even. So 1 is connected to 2. I just arrange them in a two adjacent sets, basically two different sets. So 1 is connecting to 2 and 1 is connected to 6. Okay, 6. Now 3 is connecting to 2 and 3 is connected to 4. Okay, your 4 is connected to 3 and 4 is connected to 5 also. Okay, 2 is connected to 1 and 2 is connected to 3. It was already there. Now your 5 is connected to 6 and 5 is connected to 4. It's already there. 6 is connected to 1 and 6 is connected to 5. Okay, so if I just divide them into two set, basically if you can see, we have two different set. Okay, so this is one set, this is two set. Okay, so what first point is saying is each vertex belong exactly one of the two set. Okay, so one vertex at a time can point either in set 1 or set 2, and also each edge connect vertices of two different set. Okay, so if you can see the one node, it is connecting to 2 and it is connected to 6. It is not connected to the same set. Okay, so it just connected to its adjacent or the different set. If you see for 4, 4 is not connected with 2 and 6, but it is connected to two different adjacent node, two different nodes which are present in different sets. So it is connected to 3 and 5. Okay, so if any graph is following this strategy, we call this graph as a bipartite. Okay, so let's understand with an example. We have clear what is bipartite. Now let's see how can we solve this question. Okay, So let's see, let's take this example again. Let's take, okay, so let's arrange it. So we have this 0, we have this 1. Okay, so let me just keep it like 0 2 1 3. Okay, 0 is connected to 1 and 0 is connected to 2. Okay, so that means they might not be in the same position. So 0 is connected to 3 also. Okay, and your 1 is connecting to 2, and your basically 1 is connected to 2, but 1 is connected to 0, and 2 is connected to 0, and 2 is connecting to 1. 3 is connected to 2, and 3 is connected to 0. Okay, so if you can see, this follow the strategy, like they are in a same set, they don't have a edge between them. But if you can see for this, if let's say we are taking into a same set, they are not following the same strategy, they are having a edge between them. So that means this is not a bipartite, so we just return false. Okay, let's take this example. So we have given this 0, and let's arrange this 2 like this. Let's take this 1, let's take this 3. Okay, so 0 is connected to 1, 1 is connected to 2, 2 is connected to 3, and 3 is connected to 0. Okay, now if you can imagine, these two are different set, they both follow the same strategy, like they don't have a edge between them. Okay, so there is no edge, and similarly one node of a one set is connected to two different nodes of a different set, so they are connected to this. Similarly 2 is connected to 1 and 3, so this is following a bipart, so we just return true. Okay, so now the question is clear to you, clear to us, like what is bipartite. Now let's understand how we can solve this. Okay, so now let's understand how we will approach this question. Okay, so for the bipartite, we know like there might be two sets. So this is set 1, this is set 2, and there is no edge between the same set, but there is a corresponding edge between two vertices of that. So as you can see, this is connected to 2 and this is connected to 6. Okay, so what we will do, we will color the graph. Okay, so we will color the set 1 will with respective one color, and similarly set 2 with the other color. Okay, so like every time if you go from here, let's assume this will be your parent node always. So this will be parent and this will be your child. Okay, so this will be child. So you will give color to your parent and you will give different color to your child. Okay, because you know your child will always be in different set, so you will give them the different color. Okay, so we'll give them blue. Okay, so you give blue. Now when you come to this, you will now this will be your again a parent. Okay, you will mark this with a different color, so you will mark this as blue. Now you will see your two children. Okay, so what you will do, you will give, this is your children. Okay, and this is your children. Okay, so when you go to this children, you will give the different color, so you will give green color again. Now when you come again for this, okay, now there might be, like you can see this color is already there, but this node is already visited. Okay, so if your parent color is equal to your child color, that means that is not bipartite. Okay, so let's understand. Okay, so let's start from here. What we will do, we will start from here, we will mark it as green color. Okay, so this will be as green color. Now we'll go to its children, so we'll go here and we'll go here. Okay, now we'll come at here, we'll give a different color, so we'll mark this as 2, the blue, and we'll mark its children as also blue. Okay, now after this we have to do for this. Okay, so we'll do from here, we'll go to its children, so its children is this and it is this. Okay, so we'll mark its children by a different color, so we only two color will be there, either green or either your blue. Okay, so we'll mark this as green, so we'll mark this green. Okay, and we'll do its processing. Okay, so now you mark this as green, so it is having two different children. Okay, so basically we are applying a DFS on the graph, and Now you come from 3, so it is at 2 children, so you can go either here and you can go either here. So you will go in this direction, like you have to go in both direction. First you go to this children. Okay, now you see your graph is already visited. Okay, so if it is already visited, what you will do, you will just check if the color that I am giving to this, is it same? If it is same, then it is okay, but if it is different, that means this is not a bipartite graph. Okay, so if I go here and I can see this is having the same color, so this will be okay to me. I will not do anything, I just return from here. Okay, now when I go to this direction, I will fill this with different color. I will fill it with green, sorry, with blue, because from green I am coming, so I will fill it blue. Now I have two option. Okay, either I can I will go in two options, so one is this and other is this. Now when I come to this, I have to fill different color, and I can see it is already visited and having the different color, which is green. So I'm filling green, so green is already there. Now when I come to this position, I will fill green because it is not visited. I will fill green. Then I have two options. I will go here also and I have to go here also. Okay, so when I come here, I can see it is already visited and it is not the same, like it is not having the green color. Okay, so your child color, if it is not equal to your parent color, then it is okay. Okay, you can do processing. Else if it is equal, that means the graph is not bipartite. If it is equal, that means they have a edge between them, like this, like this. So this way we can solve our question. Okay, so let's write the code for this. Okay, so what we need is we'll solve our problem. Okay, so we'll, and let's say like if you read this point, the graph may not be connected. So what we will do, we will apply on all the vertices this processing. Okay, so let's take a visited array. Let's take a boolean type, boolean visited, and let's take a color array. So we'll initialize both of them, graph dot length, and we'll initialize visited array of boolean type and color also of boolean. Okay, now what we have to do, we have to call the bypart function, which we do. So for int I 0 to n, we will call for every vertices, and we will only call for that vertices which is not visited. Okay, so if visited of I, basically if we do this is true, and if we put ampersand over it, so it's basically mean false. Okay, and also if we call the bipartite function, let me just bipartite graph, and we'll give the vertices and we'll give the color. So let's give a 0. Let's assume like 0 is green, and we'll do its reverse, it's 1. Okay, that will represent blue. Okay, so let's say if going from one vertices and you getting answer as false, so you don't have to do for other vertices, you just return false from here. Otherwise after this you just return true. Okay, so let's write the bipartite function. Bipartite, we'll take a graph, and this will be our vertex. Okay, well, let's give full name, and this will be our color. Okay, so first step is to mark your visited vertex as true. Okay, after this what you have to do, you have to give the color also. Okay, so we mark visited, similarly we will do the color also, give the respective color to that. So we'll give it. After this we will go to its all children. So for int child graph of current vertex. Okay, So if your vertex or if your child is not visited, we'll do something like it's a will do false. That means it's not visited. We'll do something else. We do something. Okay. If it is not visited, you just have to call bipartite again. Bipartite. So basically, we are applying DFS only graph and with one condition. So vertex is now become child and we'll give the opposite color. So what we'll do, we will do the 𝗁 of the current color. 𝗁1. Okay. So we are doing with 1 because with 𝗁, if you have same number, it will become 0, and if you have different number, it will become 1. And if the call from this, and if it giving false, we just do from here, we just return false. Okay. Now let's say if the children is already visited. Okay, so we just need to check if the color of parent, basically this vertex, is equal to color of child. If it is equal to, that means they both have edges between them, so we just return false from here. Rest we just return true. Okay, let's run it. Okay, let's see. So this is accepted. Let's submit it. Okay, so our code is submitted. So our streak also start from Monday. Hope you like it. Thank you for watching my video.